All right, so hello everyone. Welcome and thank you for joining us today in our very first MMID coding workshop. My name is Grace. I am the coordinator of this workshop series, as well as your instructor for today's Introduction to Bash session. Our series have great lineup of coordinators, great lineup of instructors who are all graduate students gathered to share our coding experience, knowledge that we gain from self-study and various trainings in bioinformatics data analysis. To make our workshops widely available, all lectures are recorded and will be posted on our YouTube channel weekly. Because of this, each workshop is designed to take about 30 to 45 minutes of instructor providing a lecture, followed by 15 through 30 minutes of question and answer period, which will not be recorded. Q&A sessions will be moderated by myself or Jill, our co-coordinator, and participants will have the chance to unmute and ask questions. If you have more questions after the workshop, we also offer bi-weekly Q&A sessions, Thursdays from 9 to 10:30, starting next week. So with that, I'll begin my workshop. So today's workshop is intended to provide comprehensive introduction to Bash, which will serve as a foundation and prepare participants for next upcoming Bash and R workshops. So it will be very fast-paced, covering from basic to intermediate elements of coding. By the end of this workshop, participants should be able to do everything outlined in this learning objectives. Without further ado, let's get started. So I will begin by explaining what Bash is and how it could be useful for bioinformatics analysis. In our everyday task, most of us click a lot of buttons on the website or on programs with graphical user interface, GUI in short. For example, on any data analysis website, it only takes few clicks to analyze data. Once you submit a job, website does some kind of magic and you magically get your results. But what really happens in the background, though, is that once you click buttons on GUI, specific codes stored in those buttons are interpreted in command line interface, and those tasks are being performed on computers. Then once the job is complete is when you get your results back. So what we're trying to do today is to learn how to use Bash, the command line interface. Command line interface is simply a dark screen that allows you to directly interact with the computer. And Bash is one of those programming language and a command interpreter for a Unix operating system. There are many reasons why researchers should use command line. Every program is first written and developed using command line. And often, especially in the field of bioinformatics, if someone develops a program, it's first released for use on command line only. GUI for the program may be developed within the next few months or actually never. This means that without command line, you might be very limited to using only few specific programs that provide GUI version for data analysis. When it comes to setting up your analysis, some GUI programs give very little freedom to users for changing parameters to make it easier to use or due to reasons beyond this workshop. But if you use command line, you're fully in control of setting your own parameters. Using command line, you can also analyze data much faster with less computer resource. GUI is designed to make it easier to use, so it's often colorful and interactive, but because of that, it uses up a lot of computer resource. For example, on a regular desktop, analyzing approximately 100,000 data points on GUI will likely freeze your computer, but that very same analysis on command line might take only a few minutes. Also, if you have to do very repetitive tasks such as creating and renaming files, command line can do it very quickly for you. For example, making 10 files with the same name numbered 1 to 10 on GUI took me a lot of right clicks and manual renaming of the files, but it only took me 1 second to do so on command line. Finally, you can submit your job to run overnight or go to take a break, as you don't have to watch the program to run if you automate the analysis for the computer to run. So this is very helpful if you have many other tasks to oversee in the lab and you don't have much time on your desk. And aside from these advantages, there are still many more good reasons why you should try to use command line. Now that you want to try out command line, so what is the next step? Well, there are many terminal programs freely available for use. Today, I will introduce you to some of the programs that I've used extensively when I first started out with coding. Using command line allows you to directly communicate with your computer system. This means that there is added danger of potentially affecting your actual system unintentionally. And you should be aware that there is no such thing as undo of what you just did, like Control Z, or trash can if you accidentally delete a file. So if you're an absolute beginner, I would recommend you to gain coding experience using a virtual machine first. Virtual machine is literally a computer within a computer. So if you accidentally mess up the system in the virtual machine, you can simply delete it and create a new one. The only downside I found with virtual machine is that you would have to transfer files between your data generating computer and your virtual machine using a shared folder. But aside from that, virtual machine is a great starter tool. So there is an awesome guide that provides all of the details on how to install and set up Ubuntu machine. Oracle VirtualBox is available for use on Windows, Mac, or Linux operating systems. And this is a free software along with Ubuntu Linux distribution. But you don't have to use this specific program if you know of any other software or want to explore different options, as there are many other great free programs offered. So I'd recommend you to explore for different options as well. Now, if you are more of a beginner and intermediate level and would prefer to use terminal directly on your computer, default apps are available on all operating systems. So if you're using Mac or Linux, Terminal is the default app. So simply search for Terminal and open it. And for Mac users, in the past, Bash was the default shell, but I believe Apple made a switch to using a Z shell as default since 2019. So if that's the case and you don't see a money sign beside your prompt, you can simply type the following command to set Bash as the default and start the terminal and restart your terminal. Then you'll see that money sign as your prompt, indicating that now Bash is your default shell. And if you're a Windows user, it's more complicated. You need to enable a feature called Windows Subsystem for Linux. So with this system enabled, you can use Bash terminal as if you are on Linux machine or a Unix-like operating machines. So, and using any command line interface such as PowerShell, command prompt, or additional programs that could be separately installed, you could use Bash from there too. So enabling is actually very simple. It's not that difficult than you think. So first, you just have to open up your control panel and then go into the turn Windows features on or off. And at the very bottom of this prompt, you can select Windows Subsystem for Linux. Once you press OK, then you will be asked to restart your computer. After reboot, you can install Ubuntu from the Microsoft Store and then start your terminal. So if this is your first time setting up the subsystem, you will be asked to set up a username and a password. This provides you with the important admin ability to install and remove any programs called super user. So once this step is completed, you can use any command line interface. In Windows, there are a lot of other command line programs available for use. So here are some of the programs that I've used before. Personally, I like using Visual Studio Code because the interface shows text editor for scripting and a terminal in one screen. Now, this allows you to easily work on scripts and test your codes in the terminal right away. So feel free to install any different programs listed here or other programs available in the community that are not mentioned here and test them out to find out your personal favorite. Now, if you have access to a supercomputer like Westgrid at the U of M, you can also use secure shell clients to remotely access folders, but you can also do the same SSH in terminals. So whichever you prefer, feel free to explore. So now that we can use terminal, let's actually get to the fun part of trying some coding. So this is my Ubuntu terminal on Windows. Now, if you see a prompt, you can type in your command. And if you don't see a prompt, either your job is in progress or something is wrong with the command, which stalled your terminal. So in that case, if anything happens, to get your prompt back on Windows or Linux, you can press Control-C. On Mac, you can press Command-C. Now, this is very basic. If something happens, always go back to try and press Control-C. Now, in command line, there are two types of paths to navigate through the folder. absolute path is a complete detail required to locate a file or folder, just like you see on your left. And relative path is the hierarchical path that locates a file or folder from your current directory. Most operating systems have very similar syntax and rules. As you can see here, although it looks different, default folder structure for Windows, Mac, and Linux OS follows very similar patterns still. So this is part of the reason why if you understand and know how to code in one programming language, you can quickly learn other programming language much faster. So for today's demonstration, I am going to use Ubuntu on my Windows subsystem, which follows a different folder structure than the regular Windows or Linux system. So to better explain what an absolute path is, let's take a closer look at the folders here. The very first parent directory is root, which is defined by a slash. And from our root, to switch into a directory called mount folder, we need to type in /mnt. So this is a similar process, and it goes on for the same until you reach desktop folder, just an example. And on the other hand, if you click, if you're on the relative path, like if you want to use relative path for changing directories, you can actually, it works backwards as it locates a directory from your current directory. So imagine that our current directory is now desktop, and here, so we got here using an absolute path. Now, current directory is referred with a period using relative path. So if you want to open a file in your current directory, you will use /filename. And from our current desktop directory, now to get to one parent directory above, let's say SEOG folder, then we will type // and so on. So the same pattern applies if you want to go all the way back to the root directory using relative path. Now, just to help out with understanding the path better, if we wanted to go from current desktop to downloads using relative path, we would go into SEOG folder first and then go down to the downloads path. So the relative path becomes /downloads, and for an absolute path, it would become as shown at the bottom here. With that, let's do some hands-on exercise. So if it's handy, you can have your terminal open and try the following exercise. Now, be aware, depending on your operating system, your terminal may look a little different than mine. So to find out your current working directory, you can type pwd. This is a command to print your working directory, and which shows an absolute path of whichever folder you're currently inside of. Now, to change your current directory into desktop, let's type cd and provide an absolute path. So your prompt should now show desktop here as your current directory. And you can type pwd again to check absolute path of your current directory. So notice that whatever you used here are exactly shown here. Now, if we want to try go into home directory again, this time your prompt will show /home instead of desktop. So you can try to go back to the desktop from home directory, but now try it with relative path this time. And so we're just using // So anytime there is a period inside, then it's assumed that it's a relative path that you're using. And finally, let's try moving up 2 parent directories above, just using relative path. And you can do so using 2 periods /. Okay, so as you can see, changing directories are pretty simple. It's just that at first it's kind of confusing, but you'll get used to it very quickly. And so now for our next exercise, we need to go back to our desktop directory. So we'll just go back to the desktop. Now this time, let's try to create some folders and files. So command to create a folder is mkdir, which literally means make directory. Let's create an intro to bash folder in our desktop and then go into this particular folder using cd. Also, now let's create 2 empty files named test1 and test2 using touch command. Now, to check if you actually created the file, you can list the contents in your current directory using ls function. And we see that now, you can see there are 2 files generated. And if you want to get more information on these 2 files, you can list directory contents using long option with just from ls add -l. Now this lists files vertically with more details. Now this long display of folder content is very useful and provides lots of information. You can see who owns the file in this directory. So first user ID shows who the owner is, and the second user ID shows the owner group. Right now, our files are empty, but if you do some analysis, you'll be able to see the file size as well. And right beside the file size shows the date and time when the file was created, and lastly, your file name. So of these information, the first part on your left represents file permission. Permissions are given in triad by owner, group, others. If you see the following symbols beside the file or folder, R means you can read, W means you can write or edit, and X means that you can execute or use it. So if you only see dashes with no letters beside the file or folder, it means that you have no permission. In this case, you won't even know that this item exists. So the permission symbols you see are actually represented as binary code in computer, where R is number 4, W is number 2, and X is number 1. If you created a file or folder, often you'll have the ability to change the permission to allow others to see as well. Now you can change permissions using chmod function, literally stands for change mode, and by adding up your bit numbers as shown here, for example, or by using RWX symbols. In case you're curious, if you're using a shared server for your work or lab, there will be times where someone can access or view certain files that you may not be able to within the same directory. This is because your username does not have a read permission, so file or folders doesn't even show up on your end. So when you're requesting access to certain files or folders, IT people will then include your username in the list of groups who will be able to read and write and get that permission. So just a little thing. And now that we've created a file here, so let's use the move function to either move file or folder to a different location. And you can also use the move function to rename this stuff as well. So let's first try out using the move function to rename test1 file to renamed 1. So this is the original file name, and I'm going to switch the file name into rename. And as you can notice that I'm also using a semicolon to list folder content right after I've renamed the file. So semicolon is a command separator. So this is equivalent to me typing ls in a separate line, but I'm doing it all at once with the move function to save a line for me. So we can see now that test1 is called renamed 1. But instead of renaming, what if you wanted to copy the file? Well, you can use the cp command, give the file name you want to copy, and the name you want to call that copied file. So this is the file you want to copy, and this is the new file that you've generated as a copy. So moving on, now let's create a new folder to move our files around. So we can also, now we're going to move renamed 1 file into the test folder. So we're going to move this folder into a new folder that we've created. Using ls function, we can show the list of files inside our current directory. As you notice that renamed 1 file is now not present here. So, so if you use a relative path, you can list the contents inside this test folder to see if we actually have renamed file 1 in there. So this is relative path. We just want to print out what's inside this folder. And we've got our renamed 1 file inside here. So now let's rename this test folder to renamed folder. We're going to change the name of this folder and then print out the content to see if we renamed it properly. So I'm using move function. This is my original file name, folder name, so test folder. Now I change it to renamed folder. And once I print it out, I see that I don't see test folder anymore. Instead, I see renamed folder. But now to remove the files or folders that we just created, you can use RM function, which stands for remove. So please be aware that this action is irreversible on terminal, so you should be extra careful when removing files or folders. So let's make a bunch of empty test folders. So here, test folder is my pattern, and inside this curly bracket, I set starting number and ending number. These integers in this bracket tells the computer to generate folders from 0 to 5 with test folder as a consistent pattern. You'll see test folder 1, 2, 3, 4, 5. Since we know that these folders are empty, we can use rmdir command with wildcard asterisk to match the folder naming pattern. rmdir only removes empty folders. So now after deleting the empty folders, we're back to having only 3 items in our current directory. Now we only have renamed folder left. So since this is not an empty folder, and for any folders, if you want to remove them, you can't just use rm like you would for a file. You need to provide a recursive option like shown here. And so now we've got rid of those renamed folder as well. Okay, so to create a file, now that we've deleted a bunch of them, in addition to touch function, you can also use, redirect output into a file using double arrows. So this will create a new file for you if you do so. So let's use echo function to print out a simple message to the console. So you see that this function prints out the same message that we've put it inside this quote. If you redirect echo's output into welcome text using double arrows, you won't see the output on console. Instead, you can use the cat function to view the file content in the welcome text. So if you have a very large file, printing the content into your console using cat is not ideal. You won't be able to see the very top of your content as console display is limited to a few thousand lines. So instead, you can use less function to interactively scroll up and down the file. And now if you want to quit this viewer, you can simply press Q. So, and if you want to edit the file using text editor, you can try Nano. So Nano is a file, Nano and the file name to edit. Then it will take you to an interactive editor. So, and if the file name you typed didn't exist, it will actually create for you. So in this editor, you can type anything you want and then save on your way out by pressing Control and letter options as shown at the bottom here. And then you'll be able to print out the contents here and see the text we just added in the editor. So this is pretty much it for text editing. So the more practice you do, the better you'll get. Now that we've got the basic command line skills in our belt, let's try installing and using some command line program. So before installing any program, I'd recommend you to use these 2 commands here, sudo apt-get update and sudo apt-get install build essential. So you need to provide a password to install as a super user. Terminal will remember your password for a few minutes or so you don't have to type password again until you time out. So now these commands install updated Ubuntu packages and basic dependencies to allow most command line programs to work on your system. If these are not installed, your program installation may fail. So just for practice today, we'll install Minimap2, which is a read alignment tool. Most bioinformatics tools, including Minimap2, are freely available on GitHub. If you search on Google, you can find a website with source code along with README markdown that tells people how to install the program and use their program. So first, we want to remove everything that's in our current directory into intro to bash folder. So there's nothing in there from our previous exercise. Now, then follow the steps you saw in the README file. So we can clone Git repository to your computer and have all the source files downloaded locally. And you'll see the Minimap2 folder, which you can go inside and use the make function to build a program. So we've used a semicolon. So we printed out Minimap2 folder, and then we got into it and built the program using make. Now, after make function is complete, inside the Minimap2 program folder, you can find an executable Minimap2 program here. So in order to run this program, you need to provide either an absolute or relative path where this file is each time when you run minimap2. So relative path here again, because we are inside the minimap2 folder. Now, if you want to run minimap2 without specifying any path, we need to copy that and put it into a minimap2 build into one of the default bin or binary folders. So to find out which bin folder you can copy and store minimap2 into, you can type echo $, and path. So path is a default variable already stored in our computer system. Among the list of bins you have here, now you can choose one of the bin folders and copy minimap2 into that bin. Since we're accessing the system folder, we need to use super user account again. Now you can check your bin folder where you've copied minimap2 and see, now you can see that executable permission under the root. So we got the X there, so you can use the program. Now to confirm if the program was actually copied over properly into the system bin, you can first get out of that minimap2 folder and try running minimap2 without specifying any path. So now just the program name itself. If you see this usage output, which is like a help page, it means that program is available for use. Now you can do the same for any program you install from source code. And once you move your program into one of those bin folders, it's now available in your system. So you don't even have to keep that cloned Git repository anymore in your folder. So simply delete this folder and you should now still be able to use the program. So let's try to run minimap2 on actual sample. So fastq and reference files are available in the workshop GitHub repository, and you can download the files from the website manually or simply use git clone function to clone the whole repository into our current intro to bash folder. Now, after cloning, we can see that all files are available in /data folder. To run the program, now change the directory into this introduction to bash folder. And then within this folder, we're going to create a directory called aligned and move into that directory, just because we want to save our minimap2 results in this folder. Every bioinformatics tool have README available to tell users how to run the program. So in the case of minimap2, we need to create an index first. Now, using example parameter provided on the README page, you can see it on the GitHub page. Let's create an index which has .mmi extension. This literally means that it's a minimap2 index. Now, index will be created in the same folder as where your reference file is. And you can see that we now have this MMI extension file available. And the second step with minimap2 is the actual fastq alignment step. So using that -a stands for alignment, we are now aligning our input file against the reference file we just created an index for. And by default, minimap2 outputs the progress on console. So this is your results here, as you can see. So after alignment is complete, if you check your folder using ls, you will now see a new file here called alignment.sam with a huge file size. So one thing to note, if your file size is very small or is 0, that could also indicate that your program have failed to run properly. So this is it for installing and executing bioinformatics tool. These tools are pretty simple to use, and if you want to improve your results, you can always test different parameters available on the help page and compare your results. Now, I just wanted to share or provide some few tips on how to troubleshoot commonly encountered issues. So when your program installation fails, you might see an error message like this one here. And usually this happens because you're missing dependency. One way to fix this is to keep up to date with all repository and dependencies in your shell environment. Remember to run these 2 commands before you install any programs, as you shouldn't have much problem. If you still encounter problems after running updates, take that error message and search it on Google. You'll likely find a bunch of posts with various solutions from Stack Overflow or different programming communities. Now, if you get an error message saying there's no such file or directory, make sure to check your input file path. If you get an error message saying there's something wrong with your option or parameters, you can check if you're actually using the existing parameter for that program, by referring to a help page or program manuals. So finally, let's put everything we learned today into a script now. Since we're going to make a shell script, let's make an empty file with .sh extension to indicate that it's a shell script. Feel free to use whichever method you're comfortable with. You can even use Notepad to create one on GUI. So every script needs a shebang line at the very top of the script file. Shebang specifies which programming language this script is written and tells the computer to use proper command interpreter. So there are multiple ways to write shebang, but I'd recommend you to practice using user bin environment bash for portability. So if one day you become an expert and decides to write a script to build a pipeline, this full path ensures that the script will run properly by any users on any computers, as this path is always present in the system. Now let's make a simple script that prints out a message. So we'll use that echo again and save your script. And now we can change your permission so that it's executable on terminal and run your script on terminal using relative path because you're in that folder and we didn't put that script into the bin folder, so we have to use relative path. And as you can see here, we got our first message in the console. Now to add more elements to the script, scroll down or press enter at the bottom of the script. So the benefit of scripting is that you can automate the process using variables. So variables are abstract storage location with an associated symbolic name. By putting something into the variable, you can store information and access it later, as you saw with that path variable earlier. Since you have some directories that have long path, let's store these as variables. You can use any symbolic name you'd like, and I always create a base directory where analysis will run, and data directory where our input files are kept. And you can also set up an output directory to save your results in a folder to keep things organized, and specify an input variable if you'd like, for like particular sample that you're going to run. And finally, create a reference file variable, which we will need for Minimap2 analysis. Now, to ensure that our script is running properly, I always echo out a script or a message and to indicate that this step is completed for checking errors. So in this case, for this script, let's print out one of the variables that we assigned to make sure it's saved properly. Now you can save the script and run it on the terminal again. The output shows that we got our base directory here printed out, indicating that variable was successfully stored. And one thing you should note that is anything that happens within the script always stays within the script, which means that because you ran the script doesn't mean that the variable base directory will be available on your current terminal. As you can see in the terminal, we didn't assign it, so it's empty. Now to add a little bit more complexity using the variables, let's change the script's directory to the base directory. So then inside the base directory, let's create an output folder called the script output, because this is what we assigned output directory as. Now to do this, you can use make directory -p option, which tells the machine to only create this folder if it doesn't exist. Now, if you don't use -p option, you will get an error message saying that this folder already exists, if it does, and it can't be created. So this is just one thing to use additional parameter. Again, just to make sure that our script successfully reached to creating a folder, let's add the little echo print out random message and check the script's final working directory with pwd command. And so finally save your script and run it again. So now here we can see that we see the welcome message, hi message, and this final pwd output. So the script was in this directory before it ended. So now this kind of tells us, oh, we've successfully ran the script and everything was all good. So then now it's our turn to add Minimap2 analysis to automate the read mapping analysis. So here, remember that we first create an index file for new reference files. We already have index, so it's not necessary, but if whoever is running the script will be first time, so they might not have that index file. It's always important practice to include that step in your script. So you can copy and paste the code we used earlier And to make things more fancy, instead of using the exact same command we used in previous practice, now let's use variables that we stored at the top of this script. Again, for read alignment step, you can do the same, copy and paste the code from previous exercise and change the relative path to variables that we've assigned. And let's add that output directory so that this alignment stem is saved in this output directory instead of the base directory. Now, finally, include the echo to print out a message indicating that we've reached the end of the script. And lastly, I always like to include an exit. It tells the editor of this file or the computer that they've reached the end of the script. It's just a small practice. So now we can save and run the script again. And you've just made your first script automating the Minimap2 analysis. Now, so here left is the final result that we saw earlier when we were running Minimap2 manually. Right is the final result that we got from the script we just created. So in the end, we got the same output using both manual and automated approach. And so this is one way to verify if your script ran properly by comparing the results of your manual and automated approach. So here is the complete script we wrote just in today's session. And if you were a complete beginner at the start of this workshop, you're now able to write a simple bash script to automate your task. Obviously, there are more things you can do in scripting, such as using if-else statement, for loops, pattern matching to process bulk files, and so on. But because we only have limited time and today's workshop was intended to be a comprehensive introduction to bash, if you'd like to learn more on how you can use bash for analysis, different data types, and more programs for sophisticated analysis, do please register for our upcoming bash workshops, which will be taught by Jill and Aaron. Now you have basic understanding of the coding language. You will also be able to do similar things on R as well. So I'd recommend you to stay tuned for those upcoming workshops as well. So today we were able to achieve all of the 5 learning objectives stated here. So I hope you've enjoyed today's workshop. And if I was successful at keeping you interested in coding bash, here are some of the resources that are very useful, which you might find interested in checking them out. Honestly, I taught myself how to code in bash using free resources available in the coding and bioinformatics community. Then I was eventually motivated to seek for more trainings, practice building pipelines, testing things out on my free time. So you can learn a lot by helping or teaching other people as well. And it's okay if you don't know how to do something or make a mistake, because even for me, when I help my friends out, 90% of the time, I actually Google things while my friends think that I'm doing something fancy on command line. So pretty much all the answers to your questions are available online in various forums such as Stack Overflow, other people's blogs, or on YouTube. So with that, I'd like to conclude the session, and I wish you all the best in your coding journey. Thank you so much for your time.